Integration and System Testing by Coulter Christensen, Kim Campbell, and Alex Godfrey. Integration testing is a level of software testing where individual units and components are combined and tested as a group. The main goal of integration testing is to test the interface between the modules. Integration testing is crucial because in the world today, most software applications are developed as modules by different developers. It is crucial to have thorough testing to ensure that these separate modules can function as a whole within the application. The purpose for integration testing is to expose faults in the interactions between any of the integrated units of a system. During integration testing, all the systems, subsystems, and modules of an application are assembled to ensure that they are able to function, communicate, and behave as a combined unit. Integration testing can include integration tests that consist of hardware and software. Similar to this analogy, if a company is trying to develop banking software, if you look at this image to the right, you will see different modules or functions that may take place in this application, such as login, check current balance, deposit, withdrawal, and transfer. Odds are these different modules or functions have been developed by different developers. Integration testing is designed to ensure that these different modules are able to interact one with another as they are designed, so that the deposit, withdrawal, and transfer are all able to interact appropriately with the current balance and vice versa, so that there can be a smooth integration with these different modules. Once integration testing has been successfully completed, the testers move on to system testing, which is the process by which testing teams evaluate how the numerous components of the applications interact together in the fully assembled system. The primary purpose is to evaluate if the application successfully meets the requirements that have been established by the stakeholders and the development teams. System testing also tests for faults, uncaused exceptions that might occur from input from a user or any other unforeseen issues. Other testing that can take place during system testing would be performance tests, speed, stability, load, and other error rates. We can return to the pen analogy for system testing, which would look like the top image. Once the integration testing has been completed, we assemble all the different pieces of the pen to make sure that they fit together, and then we move to system testing, where we would take the pen and we would test it as a whole. We would ensure that it writes correctly, we would make sure that it fulfills any requirements stipulated by the stakeholders. This could potentially be writing on different surfaces or underwater, perhaps needs to be able to click with a certain amount of pressure. These are all different examples of system testing to make sure that the pen actually meets the requirements set forward by the stakeholder.
I'm going to talk about the benefits of system and integration testing. Integration testing is very important because when two software components are brought together, there is a high risk of bugs being introduced to the system. When companies hire engineers to develop an application, it is usually broken down into multiple modules. Each module is handled by a separate developer, and different code and logic may be used for each module. Using integration testing, problems may arise from integration and can be found and handled before implementation. Merging multiple software components often includes a transfer of data, and integration testing can help prevent any data corruption that could happen. Integration testing can also be done while the modules are still in development, which helps with bug prevention. The last benefit to integration testing is that the tests are able to run relatively quickly when compared to end-to-end system testing. Next, we'll look at the system testing. One of the main benefits to this type of testing is that it covers a complete end-to-end testing of the entire system. System testing is often run on production after deployment, and so it can help find bugs that are happening in real time. The last benefit to system testing is that it covers both business requirements and system software architecture. Now I'm going to cover the considerations for both integration and system testing. When developing integration tests, most of the programs and data are mocked. Because of this, integration tests usually have to be done by someone with a lot of programming experience. Another implication of using mock data is sometimes when real data is introduced, there are bugs that even thorough integration tests would not be able to find. When looking at system testing, it can be time-consuming because it involves going through the entire software system and evaluating the effectiveness. It can also include many people like the developer, clients, and sponsors, so system testing can require a lot of resources as well as time.
To understand the effectiveness of integration and system testing, we must understand that there are 4 main approaches to this problem. For top-down, the testing starts with just the topmost module of an application, i.e. the UI, which we call as a test driver. The functionality of the underlying modules is simulated with stubs. The top module is integrated with lower-level module, stub one by one, and later the functionality is tested. Once each test is completed, the stub is replaced by the real module. The module can be integrated either in breadth-first manner or depth-first manner. The test continues until the whole application is built. The advantage of this approach is that there is no need for drivers, and the test cases can be specified in terms of the functionality of the system. The main challenge of this type of approach is the dependency on the availability of lower-level module functionality. There can be a delay in tests until the real modules are replaced with stubs. Writing stubs is also difficult. Bottom-up eliminates the limitations of the top-down approach. In this method, first, the lowest level modules are assembled to form clusters. These clusters serve as a subfunction of the application. Then, a driver is created to manage the test case input and output. After this, the cluster is tested. Once the cluster is tested, the driver is removed, and the cluster is combined with the next upper level. This process goes on until the whole application structure is achieved. There is no need for stubs in this approach. It becomes simplified as the process moves upward and the need of drivers gets reduced. This approach is advisable for doing object-oriented systems, real-time systems, and systems with strict performance needs. Here, the top-down and bottom-up approaches discussed above are combined together. The system is perceived as having 3 layers: the middle layer, which is the target layer, a layer above the target, and a layer below the target. Testing is done in both of the directions and congregates at the target layer, which is in the middle. An advantage of this approach is that the top layer and bottom layer of the system can be tested in parallel. However, the limitation of this approach is that it does not exhaustively test the individual subsystems before integration. To eliminate this limitation, we can modify sandwich testing, in which the integration of the top, middle, and bottom layers are tested in parallel using stubs and drivers. In this approach, integration is done once all the modules of the application are completely ready. Testing is done after the integration of all modules to check if the integrated system is working or not. It is challenging to find the root cause of the issue in this approach, as everything is integrated at once as opposed to incremental testing. This approach is generally adopted when only one round of testing is required. These are the references we used to facilitate our research. Thank you for watching. We hope you learned something.